My name is Sam Griffiths-Jones. I'm a professor of computational biology at the University of Manchester. And I was one of the founders of Rfam with, of course, Alex Bateman and Sean Eddy back in 2002 when I was at the Sanger Institute. So the start of Rfam was very much that it was going to be PFAM for RNAs. And so I had worked in Alex Bateman's group at the Sanger for a bit more than a year, I think, when we started thinking about Rfam things. And I'd worked on the protein families database PFAM and also on Interpro. And Sean Eddy had recently developed software that would let us find homologs, essentially, of structured RNAs. The software was called Cove, later became Infernal. And Alex and I thought we should be able to use that software to build RNA families. So this is something Alex had talked to Sean about, I think, over a relatively long period of time. But we thought that with Sean producing this piece of software that we could actually do it now. It could actually be done. And so the vision was kind of clear, actually, as I say, to be PFAM for structured RNAs. And so we wanted to have as comprehensive a catalogue as we could of families of these structured RNAs, and they would be represented by multiple sequence alignments, as protein families are represented by multiple sequence alignments in PFAM. And they would be, those multiple sequence alignments in the case of Rfam, these RNA families in Rfam would be annotated with secondary structures, so with base paired information, secondary structures. And then from those multiple sequence alignments, we could build models. So in PFAM, they're profile HMMs, hidden Markov models, but in Rfam for RNAs, they're called covariance models. And so we could build these covariance models from these structure annotated multiple sequence alignments, and those covariance models could be used to find other members of the family. So homologs of the family that we were building, essentially. And crucially, we were really interested in being able to do that in genome sequences. And so as complete genomes, as genomes were being sequenced and completed, then we should be able to annotate homologs of these structured RNA families in those genomes. And that was going to be a real first. That was something that you couldn't previously do for multiple families at the same time. So the very beginning of Rfam was so the very early days were a really fun challenge, largely because the amount of time that passed between Alex and I sitting down and saying, actually, let's do this thing, and actually having something that was out there and working was really short. So I have an email thread, actually, which I go back to every now and again, which was from March 2002, where Alex emailed Sean Eddy to say, we want to do this thing. We think this is the time. We think we should do this thing, PFAM for RNAs, Rfam. We should actually, make this work. And Sean replied really fast with, "Great, that's ace. I'm really supportive. This would be a really great thing for the field." But I'm not sure we're actually ready to do it yet because we need a sequence database. So PFAM is built on top of UniProt. So we need you have a database of protein sequences, and you use those protein sequences to build these families of protein domains. And Sean was saying, well, hang on, surely we need UniProt for RNAs. In fact, I think you even called it UniRNA at the time. We need UniRNA to be able to build Rfam. And there's this great line in this email that says, "Else there will be relative chaos." And Alex replied, Alex and I talked about this, and Alex replied with, "Yeah, well, we're going to do it anyway." And we had this plan that we were going to, we were lacking this sort of database of RNAs that would let us actually do what PFAM does. But instead, we were just going to search all of the known nucleotide sequences. So essentially, we were going to search the EMBL nucleotide archive, which was actually a kind of a bonkers thing to try and do. But this was the plan. You know, we're just going to do this. And Sean, as I say, stuck with this kind of idea that there will be relative chaos, and you could argue that was exactly what happened. There was some relative chaos, but we made this thing work. But there was a load of other stuff going on at the same time, because we were sort of committing to doing this thing, but we were also requiring a bunch of work from other people. And Alex's next email, as I say, this was March 2002. Alex's next email said, "Oh, and by the way, we would really like to have something working for August so that we could submit a paper to the nucleic acids research database issue." I think the deadline for that was August the 15th, I think, to submit a paper. And so in March, we were saying, we're going to do this thing, and we're going to have a working website, and we're going to have some families, and we're going to have written a paper by the middle of August. At that point, we had no pipeline, no families. Sean pointed out that actually Cove at the time, as I say, later became Infernal, but the software that we needed to do this was missing an essential component. It was missing the component that allowed you to align sequences back to a model. So it's now called CM Align, that component. And so we had none of these things. And not only did we have none of these things, but Alex and I were not able to produce some of these things. Alex and I spent a load of time building families, building the first set of families, but we needed a load of other people to do some work, including Sean, to write some proper code, some proper Infernal code, to have a component of this working in time, which of course he did. We also didn't have a website. The team, the PFAM web developer, Viri Marshall, built a website really fast. A lot of this was based on essentially forking PFAM code and changing all the P's to R's in order to change PFAM to Rfam, proteins to RNA. But there was an enormous amount of work to be done in a very short period of time. And as I say, Alex and I were mainly on the family building side, building multiple sequence alignments of RNAs. Sometimes that involved typing them in from papers. So we would find published alignments in papers and type them in. And then we would run Sean's code, Cove, as it was called then, to build these families. And Cove was enormously resource intensive, huge amounts of memory, huge amounts of compute time required to search any sensible sized sequences for homologs of these RNAs. And so there was a fun couple of months where I was, by quite a long way, the biggest single user of the Sanger's compute farm as we built the first versions of these families. But build them we did, and the success, I guess, was that we did actually submit a paper describing the first version of Rfam. I think we submitted it on the 15th of August, which is the deadline. I think Alex and I, if I remember rightly, wrote that paper in a little bit less than a day, having been down to the wire of getting these things built. I think there were 20, around about 20 families, maybe it was even 20 families in the very first version of Rfam. And there were a bunch of successes that sort of came fairly quickly from that. One that I mentioned earlier is that one of the core aims was to be able to annotate RNA sequences in complete genomes, because that couldn't really be done, or it couldn't be done for multiple families at the same time, at least. And so as soon as this thing, Rfam, had a life, then there were lots of new genome projects, lots of people involved in new genome projects who were really keen for us to help out and be involved. And so we got involved in a bunch of genome annotation projects, and that was really really ace. Apart from the teleconferences, a lot of extremely long telephone conferences, long before the days of Zoom, just on rubbish phone lines, crackly phone lines, discussing the progress of these big genome projects. So maybe that wasn't quite so fun, but otherwise that was all enormous fun and really kind of intensive and stressful work, but everyone pulling in the same direction in order to be able to get this thing up and running really fast. Really satisfying thing to do. I think the Rfam of today is pretty close to what was originally envisaged. Um, so you could argue, of course, that the RNA world and the RNA sequence analysis world has developed a lot in the last 20 years. But Rfam has always had the same aim, essentially. And the core aim is to be able to represent families of structured RNAs with multiple sequence alignments that are annotated with secondary structures, and to build models from those alignments that allow you to detect homologs of members of that family. And that aim hasn't changed, and I would argue shouldn't change, because that is the thing that Rfam does, and that is its contribution, essentially, and that will remain its. I think that will remain its contribution. And so, producing a sustainable resource, a biological sequence resource, is a real challenge, and producing, Rfam with that aim is a real challenge. And of course, it's grown in size and it's grown in complexity over the last 20 years. Of course, enormously, from 20 families, I think, as I said in the first release, to somewhat more than 4,000, I think now. Real, pretty stunning growth actually over that time. But the aim remains the same. But in order to grow in size and complexity, not only in the number of families that Rfam has, but also, of course, the amount of sequence that it has to search. So in order to produce its families, if you want to continue to search essentially all of the known nucleotides, even all of the known RNAs, but particularly all of the known nucleotide sequences, then you've got to get much more efficient at this. And I'd said already that the first versions of the software that Sean had written to do this were really, really intensive, both in time and memory. But Eric Norocki, more recently, and Sean prior to him, had done some amazing work in making Cove and the successor to Cove, Infernal, be fast and scalable and up to the job, and that's allowed Rfam's growth, but without changing this core sort of underlying philosophy of what it should do. I think there will be efficiencies, I'm sure, in the family building process that I hope none of my crappy Perl code from the very first versions of Rfam still exists, but occasionally I hear that there are still some little bits kicking around. But the system, as I say, the system in terms of its overall aim, I think has remained pretty much unchanged, but it has to get better. It has to be much more efficient in order to deal with the size and scope and complexity that the RNA sequence analysis world has developed into over the last 20 years. I think the core aim of what Rfam does shouldn't change, and I hope it doesn't. And anytime I have the opportunity to talk about it, I argue that it shouldn't change, because it has a place. The thing that Rfam does really well, it will continue to do, and as long as it can be scaled to meet the demands of ever increasing number of known RNA families and ever increasing space of sequence that you need to be able to search, then it should continue to have that core aim. Now, of course, there might be all sorts of things you want to layer on top of that, so it can become, that system can become the kind of the backbone to all sorts of other data types and information types. And so you might want to layer, I know there are plans to layer on various other types of information. 3D structure is an obvious one, for example, on top of the alignments and models. But as I say, I don't think you want to change the core aim of what the thing should do, what Rfam should do. It will need to do it in a more automated way in order to be more to continue to keep pace with the incredible speed at which we generate sequence these days. And so it will need to be more automated, it will need to be faster, it will need to be more efficient. But and it will need to continue to grow in terms of number of families. It will become larger and more comprehensive and more representative over time. But actually, I kind of hope that, other than that, I hope that not that much does change in Rfam. I think that core aim should remain exactly the same.